Back to this 64-ish Vox AC10. I'd hoped to have this done closer to Thanksgiving, but the parts that I ordered arrived about 7 days after I expected them to, so no, that did not happen. However, they did get here, and we are in a much better place. Let me take you through everything I've done so far. Here at the input jacks, besides the fact that the old resistors were worn out and noisy, they wired the AC10 inputs to have a voltage divider. So they have the two 68Ks joining together, like I have here, and then they have a 1 meg to ground, which means that you have the same signal on each pair of inputs per channel, but that has attenuation. 68K, then a 1 meg forms a slight but real voltage divider. So I've wired this the way they did the AC15, where the top input has no voltage divider and has a 1 meg input impedance and no attenuation, and the other input down here for first channel, down here for second channel, is like you find in a AC15 or a Fender or a Marshall, where the second input is slightly attenuated and a little bit darker. It just gives it a little more flexibility depending on what guitars you're using, what sounds you're going for, and it's nice to lose that little bit of inbuilt attenuation. Here on the board you can see I've changed out this bypass cap and this bypass cap over here. Sorry, I couldn't see where I was looking because the camera's between us. And aside from the original carbon comps, which tests fine, and this little series thing here making up a 750K and one other 330K over here, I've replaced all the mismatched resistors that were in here before with consistent half-watt carbon films. I'm going to order the 750K here, which is a value I don't normally stock, and I'm out of 330Ks, so those will get changed later. But I want to power it on first to make sure there's nothing else I need to order to get everything right. Here you can see the new F&T dual 8 microfarad. Very neat. It's clamped on cleanly and securely with the original clamp. All the connections between the two chassis were undone and cleaned and redone. So these things have a steel bottom chassis and then an aluminum top part of the chassis, and where those things mate over time, those get loose, dirt gets in there, funk gets in there, and that chassis to chassis contact between the aluminum and the steel is part of the whole ground for the entire amp. So that's been redone. You can see the changed out half-watt carbon film resistors, like I mentioned. I put in new output coupling caps, and I chose these Panasonic ECQ polyesters, not only because they look like chiclets or something tasty, but they have very little mass. And given how fragile these tag boards have become, and there's a lot of damage to them, I'll show you more on that in just a moment, these low mass 47 nanofarad 630 volt Panasonic ECQs made sense because a larger axial with a little more weight to it, a little more mass, might put some strain on the very fragile tag boards. Here you can see that this tag and this tag on the other side had broken off due to the previous techs being clumsy. But these little tags have these little terminals have a tag here and a tag here and then a hole in the middle. So for this capacitor, the leads are going down through the hole on both sides. And for this resistor here next to it, hopefully you can see it, this end is on a tag, but this end is also going down through that middle hole. There just wasn't any metal left, and as I went through the amp, there were places like here where this tag looked like it was in place, but it was actually broken and just being held in place by solder, and this entire end of this capacitor was vibrating wildly because that solder was beginning to break, and solder is not a mechanical component. So I've reattached this end of this cap to this undamaged end of this tag, and things like that throughout. Here's another one next to it with the tag was missing, so went down through that center hole. None of this is the way I like to work. I've worked on a lot of these. I think I broke one tag very early in my efforts on JMIs, and I learned, oh, don't do that. So after that, I have not. But when you go through these things that have been previously worked on and you find gobs of solder, I'm always suspicious, and many times when I remove that big gob of solder, I find that there's nothing mechanical there whatsoever. It's just a big ball of solder, and that's not so good. As far as the pots go, they all seem to be okay in my initial test of this amp. I've given them a cleaning. Beyond that, nothing. Fingers crossed that that's all they'll need. This screw here on the other side holds a terminal strip to the chassis, and that gives a ground point for the the power transformer's HT center tap and the shield connection for that power transformer. So that's a ground being made on the other side, and it was also being used on this side as a cable clamp and the AC ground. Now, I prefer to have AC safety grounds separate from any system grounds, any circuit grounds, but in an old amp like this, my options are somewhat limited. I don't want to start drilling things everywhere. So I took all this apart and I cleaned the metal on both sides, including on the side that you can't quite see right now where that terminal strip is. You'll see that in a moment. And then I rebuilt this with a very nice Keps nut and a new ground lug. So while the ground is being made for the power transformer HT center tap / shield and the AC safety ground at the same point, I know that is a good, clean, tight connection on both sides. And you can see here the AC safety wire ground, the AC cable safety ground, is physically longer than the hot and neutral. So that should something go wrong and this were to pull out, though that is a very secure connection here. Sorry about all the shadows. This was an existing hole, so I put the cable holder here. This is nice and tight. Should this pull out, which is unlikely, but it happens, one of these, the hot or the neutral, would break before the ground would break. So if one of these pulled out and touched the chassis, it would short, it would trip the fuse rather than make the chassis go live. So that's nice. You can see I've got the existing fuse holder, which was not original to the amp, but that's fine, wired correctly with a hot going to the inmost point, and then the sleeve connection going to the one side of the new double pole single throw switch, a Carling, and the other side gets the neutral. And then these really pretty red and white wires for the primary connections. These are not original. If you see the previous video on this amp, you will see previous 2 videos on this amp, you'll see that there was just a big Charlie Foxtrot of taped off unused primaries, which are not specifically great to have. So I have moved them, and I'll show you what I've done there. It's not my preference to do that. I would have left all the old primaries connected here to the voltage selector switch, but someone had cut them off, which meant that they were all too short. And then I just would have, rather than having the wire from the common of the switch go to the power selection, I would just have that wire go straight to the 115. I'm going on too much on that. If you know, you already know. If you don't know, you don't know what I'm talking about, and I don't have time to do the full explanation right now. But there's a better way to do this, but I was too late to implement it. I'm making do with what we can. So anyway, all this is very nice and tight. Before I show you the output section, wiring changes. This is the other end of that power cable. It's a very pretty, more importantly, it's a very rugged plug. This is a hospital grade plug. So an amp this nice deserves a really nice power cable. Down at this end, you can see the red and white new wires coming through. And I've got them nice and twisted. And they are spliced to the old common and 115 wires off this transformer. Fun fact, the wire colors on this existing power transformer did not match the wire colors given in any of the diagrams or schematics for this model. So they used a different vendor's power transformer that week. But anyway, I've identified that the white is the 115 tap on this. The red is the common. Let me get my notes out. For anyone else who runs into one of these, I'll tell you what the wire colors are on this particular 64 primary. All right, so the red is the common. The white wire is the 110 or 115. The blue is the 160. The black is 205. The green is 225. And the yellow is 245. So if you get one of these in and all the primaries on the power transformer are red, white, blue, black, green, and yellow, versus the ones given in the schematics and layouts, I just saved you about 15 minutes worth of measuring and frustration and hair pulling. None of this would have been necessary if a previous tech had left all those wires connected to that voltage selector switch. This is the terminal strip I was referring to that shares its screw with the AC safety ground on the other side. And these are the heater connections. They're not tied to anything. It's just a junction. And here is the HT center tap and shield connection for the power transformer. So the angle looks scary. It's not. It's going to have wood beneath it, so it's just fine. But these things get fragile over time, and I didn't want to start torquing it. It could have broken. In this area, it has a new F&T dual 16 microfarad 500 volt cap. Might be 450 volts, I don't remember. Either way, it's more than adequate for the relatively low B+ in an AC10. I gave it its own dedicated new chassis ground connection here. It used to make its ground through this shared one here, but I don't like having terminal strip grounds be used when I can avoid them, so I've moved that there. The choke is here. I'm going to either side. The wiring on these is a little unusual. So this is the output of the EZ81, which goes to this side, and the choke and nothing else. On the other side of the choke, it goes to the screen node, which has no resistors with it on an AC10. And it from this also has the center tap tied to it of the output transformer, and the primaries are these little yellow ones. And on the AC10, the primaries have 100 ohm resistors, not the screens. It's kind of an interesting thing. It's one of the ways they made the AC10 not be as loud as the AC15. The output tubes are being run pretty much in a triode mode, semi-triode mode operation versus the pentode operation you find in the AC15. Though they fudge that a little bit too on the AC15 because of where the choke is. But I digress. And then the other wire coming off here goes to the subsequent preamp stages, and all the dropping resistors are on that board. So that's why the wiring of this cap looks a little bit different than you'd find in a Marshall, say, 18 watt of the same era. I've got the original 130 ohm Welwin resistor here for the cathode bias circuit. I will test it to make sure that 130 ohms really is a good choice with modern wall voltages. And tucked down beneath that is a Vishay 47 microfarad. I think it's a 63 volt cap. It's either 63 volts or 100 volts. I can't see it from here. I don't remember. Either one will be fine with a nice air gap between the resistor, which could get warm, and the capacitor, which does not like such things. Even though it is rated at 105 degrees, let's not test that. Unless there's some problem with these resistors, this is a previous tech's work, and it seems fine. Given the low current and voltage in an AC10, I think these 1 watt 100 ohms are probably okay. They measure fine, and the stock 1.5K grid stoppers will do. On the control panel, I haven't done much other than clean it up. I mean, you can see it's got a new short bat power cable, which is appropriate, and it's got the pretty dress washer, whatever you want to call it there. And while the switch voltage selector is purely cosmetic at this point, I did move it to indicate that this has been wired for 115 volts. And as it came in, all the knobs were in different orientations. They didn't line up with each other. So I removed those, cleaned everything up, tightened all the hardware, and put the knobs back so they all line up. And I removed the nuts off the input jacks, cleaned all the plastic carefully, cleaned around it, and put them back together nicely. And on this end of things, you saw in the previous videos that I got in here with naphtha and got multiple decades worth of grime and grunge out, and that revealed some rusty spots. So I rubbed them all with WD-40 a few times, wiped off the excess, and then left a light film just to retard rust returning at any noticeable rate. I did the same thing for the end covers of the power and output transformer here. cleaned all the connections between the chassis and ground. You already saw me fix the flanges on the choke. And for those of you wondering what that big red elephant in the room is, the choke on this particular amp had exposed metal connections here, where if you were to reach around behind the amp to change a tube and the amp was on, or the cap had not discharged, you could electrocute yourself. So I got some liquid electrical tape, Star Bright, it's about $12. I chose red. It comes in other colors. And what's nice about this needs one more coat to really get the right thickness there where the metal is kind of pointy, is that once it's built up 2 or 3 coats of this and it's cured a day, you could touch this while the amp is on. You won't get electrocuted. And if you ever need to undo that, it's rubber and it peels off. You could peel it off pretty much with your thumbnail. And especially in this case, aside from the metal surfaces where the rubber can be easily scraped off without marring the metal, the rest of this surface is waxed, so that red rubber is really not sticking long term, just enough to keep you from saying, hey, what's that do? Zap. Before I put the tubes in and power this on for everyone, I want to change the fuse in this amp, because this amp came into me at 245 wiring, and it has a 1 amp fuse. And while the amp would work at 115 with a 1 amp fuse, if you played really hard, odds are it would blow and make you think that the world was ending and something was dreadfully wrong. It's just not really rated for that. So I'm putting in a 2 amp fuse. I might order a bag of 1.5 amp fuses for this owner, because 1.5 amp is probably perfect for one of these, but 2 amps is probably going to be just fine. It's a much more common value. I'm making sure the tube holder isn't wanting to move as I tighten it, on the, moving on the other side, because if you have a fuse holder that turns and spins over time, wires can twist and break. Feels like it's solid on the other side. I know that makes for a real compelling video. All right, let's put the tubes back in. So I've got an EZ81 with nice corroded pins. So at the very least, I'm going to run these pins into the metal soldering sponge, whatever you call it, this brass bunch of stuff. And that usually makes these a little bit shinier, gives better contact, and it's pretty easy to do. I need to fluff this up. We've got a Brimar EL84, another Brimar, though the label's almost worn off. Label's pretty much gone from this 12AX7, but it does say made in Canada. This 12AX7 ECC83 I'm not going to use. I don't know how well the camera picks it up. There are flecks on the inside of the glass, little spatter things from the inside that are now on the outside wall. So I'm going to put that to the side. And it's got this nice Brimar EF86. All right, moment of truth. Time to power it on. Before I do that, I want to note that the tube with the flex on it that I do not trust is an ECF82. I do not have another ECF82, so we're going to try it with that tube. But I've already looked on Tube Depot, and I can get a new old stock ECF82 for about $15. So not a big deal, but I think between the current limiter and the fuse, we can test it. So let's power it on. And no, with new capacitors, filter caps, I don't form them slowly using the Variac. I just turn them on. If a brand new cap were to fail from that, then there's something amiss with that cap. There's a bit of hum in the background as soon as the amp is turned on, before any current can flow, because that rectifier tube and the other tubes have not warmed up yet. So that's just going to be a field from the power transformer being picked up by the output transformer. We've got a buzz here and some scratches. And the volumes of both channels are off. So I suspect we may have a bad rectifier, not rectifier tube, sorry, phase inverter tube. This generic made in Canada ECC83 might be the cause of that. So let me put in a brand new JJ. I think a 1964 AC-10 can do better than just a JJ. There's, nothing wrong with using JJs if you want, but I think we can get something nicer. But I'm curious to see if all that buzz and crackle goes away with the new tube. It seems to have. So let's try the vibrato channel first. Vibrato channel uses the EF86. All that sounds very good. I'm not going to blast it right now at full gain because it'll just sound like hell through the overhead mic here. Interesting, when the vibrato amplitude knob is turned up with the tremolo off, it gets louder. All right, it's been about 10 years since I had an AC-10 on the bench, and I just don't recall. Most of us would expect, as you turn the amplitude up, meaning clockwise, that the amplitude of the vibrato would increase. Instead, counterclockwise is loudest, strongest vibrato, and clockwise is minimal. So I will confirm that that is the case, and I also want to look into this thing that when the LFO is turned off, there's a noticeable increase in gain on the channel overall when the amplitude is turned fully clockwise. So I'm going to make sure that that's wired as it's supposed to be and that no little mistakes were made along the way by anyone. So let's try the normal channel. This is the one I have diminished expectations of given the physical deterioration of that ECF82 tube. All right, it's got really low gain, and it's got a lot of DC on the input. And that won't work. Now, I already looked at the schematic, and I know that all the components used by that triode of the ECF82 to give us the normal channel have been changed. So we've got a new 220K plate, we've got a new 820 cathode, we've got a new bypass cap, we've got new grid leaks and grid stoppers on it from the input. So the only thing that can be the fault here is that ECF82, and given that physical damage that's visible on it, I'm just going to have to get another tube. So we're going to get a new 12AX7, ECC83 for the phase inverter. We're going to get a new tube ECF82 for the normal channel, which also does part of the LFO for the vibrato channel. And I'm going to investigate that amplitude wiring to make sure that it's supposed to be counterclockwise is more trim, and also that insertion loss when that is set to max. That might be JMI, but we might be able to tweak it without losing what makes the amp special. So all that's coming next time. Thanks for watching.